So in this video, we're going to take a look at how you can organize data and display it in various forms, and then draw conclusions from the displays. So the objectives then, there's two. One is to analyze categorical and quantitative data using various displays. We'll define both of those words for you. And then we're going to use various data displays to answer questions. And it's a wide range of questions involving comparisons, predictions, increase or decrease, and even some percentages. So first we'll take a look at categorical data. So right there in the word categorical, you have category. And categories aren't always numbers. I mean, zip codes are types of numbers that happen to be categories, but a lot of times it's not. Like for example, we could say, we could categorize grams of fat, and they could be grams of fat that are in bread in a sandwich, or ham, or turkey, or cheese, based on this graph here. This is called a bar graph. And bar graph is going to show a number of grams of fat that comes from each category. And there's sometimes side-by-side bar graphs where they might have two different sandwiches, where they would have two different bars under the bread and things like that. But this is just one where I just wanted to show you a couple examples of types of things you can do if you're comfortable reading a display. So one thing you could do is you can make comparisons. You could see from this, the longer the bar, the more the grams of fat. You can tell that because of how the numbers are labeled here on this axis. And you could answer questions like, how many more grams of fat are there in mayonnaise versus turkey? So if you think about your problem solving, it's going to be a big piece of how comfortable you are in this chapter. If you think about how many more grams there are in mayonnaise versus the turkey, then I would want to know how many there are in the mayonnaise, how many there are in the turkey, and I'd subtract. So the bar stops at 11 for mayonnaise. It stops at 3 for turkey. The difference between 11 and 3 is 8. So there's 8 more grams of fat in the mayonnaise and the turkey. Tons of other questions we could ask. What I wanted to do is touch on percentages, because I know that that's a very common way to describe things, but it's also something that I think students have some challenges with earlier in their math career at least. So approximately what percent of the sandwich's fat is contained in the cheese? So whenever I'm asked for a percent, I always step back to the big idea, which is percent is always part over whole. And students do best with this with their grades. If I hand back a quiz grade and it says 11 out of 38, students not only know that they're probably not happy with that grade, but they can also grab a calculator and do 11 divided by 38, get a decimal, and they'll see what their percent is. There's never any doubts about how many decimal places to move or what should be divided by what. But big picture, anytime we change something out of it besides a test grade, people do doubt themselves. So it's just part over whole. So interpreting this question as part and whole, cheese fat is the part, and total grams of fat in this sandwich is the whole. And that's the fraction that's going to help us approximate the percent of the sandwich's fat that is contained in the cheese. How much is in the cheese versus how much is there altogether. So cheese grams, just like before, that's 9 cheese grams. So we'll put that as a numerator. And for the total is, we'll assume the bread, the ham, the turkey, the cheese, the mayonnaise, we'll leave out anything else that might be on there. So the grand total of those 5 numbers then is 30. So the percentage then, just like if I were to hand the quiz back to you, is part over whole, 9 over 30. And if you divide those in a calculator, you get 0.3 exactly. And if you're turning that into a percent, we should know that's not a 3%. Because you move a decimal point 2 places, you get 30%. 0.03 is how we would have done 3%. So it seems like we can answer a question, and you can imagine there's a million different questions we could ask based on that one graph. But I just wanted you to see how it starts by understanding how to read a bar graph. Let's start talking about quantitative data real quickly. Quantitative data, the root word there is quantity. And like I said, zip codes are numbers, but they're not quantities, they're categories. Quantities are usually numbers that can be averaged. So if we were talking about hours of the day versus temperature, we could ask for an average temperature for the day. So we could average temperatures if we wanted to. So this is quantitative data. A line graph is good at showing how quantity has changed over time. So because this is an amount of time, we see that a lot of times going from least to greatest amount of time, you can see how things are changing. It looks like the temperature grew for a while and then decreased, and that's sometimes just the story they're asking for. They might talk about rate of change too. But I chose to do this line graph to answer a couple questions. This is apparently months, another element of time down here, and the number of visitors in thousands to a certain website. So understand this is 1,000, this is 2,000, not 1 or 2. And we'll get to work. Did the number of visitors increase more in the time between the months 0 and 2 or in the months between 4 and 6. So they're asking us the increase, not the number of visitors, but the increase in the number of visitors. So the increase in the number of visitors between 0 and 2, the two pieces of information I would need there is I would need to know how many were there 0 months in, and I guess it would be 0, that makes sense. And then how many visitors are there 2 months in, and according to this dot, it would be about 2,000. So we know that there was an increase of 2,000 between the months 0 and 2. Now we have to compare that between months 4 and 6. So we would see what is the height, or what is the Y value, or what is the number of visitors, about 3,000, maybe a little bit less, 2,900 or so at month 4. And then at month 6, it had increased to 3,600. So while this is the biggest number on here, the difference between 3,600 and 2,900 is not nearly as big as the difference. So when they ask, did the number of visitors increase more in the time between month 0 and 2, or between 4 and 6? Since it grew by 2,000 between 0 and 2, and only 700 between 4 and 6, it would be between month 0 and 2. And the last thing I wanted to do here was, this is a very popular keystone algebra topic in Pennsylvania, which is these ideas of using the dots here as a scatter plot. So if we removed these lines that connect there especially, you could think of this as a bunch of paired data, months and thousands of visitors. And what I say here is you could approximate a trend line, and that's often used to make predictions about the future. And in other portions of the course, we concentrate on writing an equation for this. But for now, we'll just use the visual, because this is what this chapter is about, is visual displays of data. So which is the most likely number of visitors in the 12th month? Well, you can't use raw data because they didn't go out that far. But you can use the idea of this trend that's sort of developing here, which is it's certainly increasing a little bit. It's increasing sometimes a little bit faster, sometimes a little bit slower. It was actually a little dip here. But in the general trend, I would say that this number line is, or this line that I drew here, it's approximating the general trend. And there's not much reason for us to guess that the trend would change, because even this little dip here at the end, it's not the first dip we've seen. So let's assume it's going to keep on trending up. And then that's also why they're saying most likely. Anytime you go outside of the data that you have, you're really not making a, you're making an estimate, an approximation, an educated guess. So which is the most likely number of visitors in 12 months? Well, now I need to look 12 months in, and I don't have a dot there, but I have this trend line, and it would seem it's slightly above 8,000 visitors. And when I look at the choices I was given, 8,000 seems to be the one that makes the most sense. So I certainly didn't give you every type of example for every type of data display, but what I'm trying to encourage you with in this video is understand that data displays are going to show you categorical or quantitative data, and then the rest of the problem solving is sort of up to you and anything you've learned in any class or any life experience up until this point.